we're not. Let's go ahead and move forward. Yes, that's what I'm looking at. This whole what view thing is driving me nuts. But the resolution. Into mostly house. And I to this side again. Actually what three things that we actually care about. Resources, control of those processes and resources, and packaging the container itself, like the container and how you right. So Rich. Mention, because he doesn't know, talk almost 8 years ago. Yeah. 2016, you and I gave a talk on what and how containers actually are. So there is material pulled from that, and I may or may not switch to the slides from that, because I have pre-existing slides from 8 years ago that are accurate. I checked them last night. So the first things that we actually care about are namespaces. Now, okay, a namespace. By definition, the wordy form here, effectively, namespaces are a way to actually segregate resources, whether that's disks, process, networks, everything that you have a resource type for in the kernel, you actually have the ability to have namespaces for. We refer to namespaces both in what it is and what they do. It's just one of those common kind of names. So let me just visualize this when it comes to process namespaces. Okay, you have the parent, or effectively 0 on the machine, your host kernel's process space. Okay, that's the root namespace. Then you can have a process there and a process there, and you can spin off a second namespace. So we have PID1 and PID2, but then we can actually have PID1 inside of namespace 2. PID1 isn't always PID1. Sometimes it's somebody else's PID15, but your PID1. This is how you start a container. When you say, Docker run busybox, actually fires up a shell, and if you look, inside of that container, it's PID1. To the host, it's like PID 16,010, right? Process. Same thing in the spaces. Now, believe it or not, even given. So, if you go down to, what does this actually do, though? It's one of the building blocks that's used to explain isolation of resources. Not specifically the kind of control that you have with C groups. That's another thing that we'll talk about in a minute. But this that we've shown, I haven't shown you. Because there's slides from Rich and I's talk. Basically, what this will do in this regard is, when you start a namespace, it's not necessarily just for that. You can start a namespace in the current directory you're in, and it will set where you're at. That ns enter is a particular command. I will go do that demonstration. The key thing that I actually wanted to say on the slide was, you can run all the commands that we'll talk about in a second, but you don't want to have to manually do this. This is why we talked about this in the previous session, about the amount of complexity of running these commands and remembering in what order and how. That's why frameworks exists, and this is what Docker and Containerd, Rocket, the actual container runtimes actually do under the hood to separate them. In short, I can point out PID. You can do it, yes, for users. How do you think you get a fake user inside of a container? You can tell the container that it's root, but in reality it's not. You can tell the process it's PID1, in reality it's not. You do the same thing with mounts. Like, maybe you don't want your container knowing that your host mount is on NVMe, you just want it to think it's, somewhere. You don't need to run mount tech A and inside the container see all of your host's mounts. You don't want that. So we don't tell it those exist. Namespaces for mounts. Grab the slides. Start talking about it. The details. I wanted to go into namespaces. I can. Anybody want me to go into more details about namespaces? I'm going to go through a couple of demo commands, like showing you changing in and out of namespaces. So, in that namespace. Because if your process, clearly, is not in the namespace, how in the world does anything inside of that namespace know about it? If you do PS, as an example, right? You run the command, you start some service, and then you switch namespaces into a new namespace. You can't tell Postgres is running because you have no idea from inside of that namespace. Let's get past the names. Yep. It's not PowerShell. PS is actually the command. And it's actually, what's the S in PS stand for? Yeah, it does do a process list, but I was like, I think it's process show. My brain was like PSLS, but I don't remember the exact actual name for what PS is. Yeah, back when, characters available was lower. Cool. So the short answer is, as you saw on the, literally just going to be following this demo here. But, so I've got screen running. If I do ps aux grep screen, I can see my process for screen, right? So if I do ps ea as is listed, Although looking that way and trying to type does mess with keystrokes. I apologize. You get all the giant pile of stuff, right? Well, if I control A, N, control A, C, there we go. Now I'm in a different session inside of screen for the sake of it. I'm going to do unshare P F. No, fuck. We're going to do that over here. That's great and fun. What should we do that? Okay, I did indeed. Unshare. Yep, I've got it. Alright, since that one does actually work and I need to go figure out what broke in my Sane file. Cute. Let's try this again. Open screen. And we're going to do PSEA. Right? There's our temp content, then it's processes. Let's unshare. See, that one actually worked. Right? Now, A, C. Now, if I do that same PSEA, move that back in here. I'm root. I can see everything, right? Where did it all go? Well, I haven't, this... I'm switching between screens instead of trying to have you read it side by side on it. Right? So then, I've got this one here. That's nothing, so I'm going to go over to the AN here, and I'm going to do sudo su. Alright, so I'm rooting this one here. And I'm going to make this easy on myself. I should probably do that. At least now we can read it easily where we're at. So, unshare, and bin dash. Does that look right? Richard, am I doing this wrong? That's what I thought. So I'm going to reprivate slash. It does not like that. I have containers running. Yeah. Oh, because I'm not reading the rest of the command. It's a wraparound. He has it one line and there's a colon and then there's actually mount tempfs. It did register. They're like, oh, there's more there. I'm like, dash T seems like a weird flag to have by itself. Yeah. Get back over here, right? Still there. Still works. And from out here, you can tell, it's like doing this, getting over my keyboard, which is messing with my spatial. You can see all of that on this one. Yeah. So that's just a quick and dirty, like, this is what NS actually do. Now, if I pop out of this one, that just gives us a quick example of that mess. Right? Exactly. Now the namespace is no longer in use or exists, gotten rid of. So if we do the same thing and we were to actually use ns-enter for PIDs, this is where you can actually use to create the namespace, start processes under it, and then from outside actually just get a shell into that. Yeah, effectively, there's that. If we were actually to, do I have running documentation? I do. Let's see. Nope, no toolbox in there. Okay. I was just thinking that I'm like, I can show, wait, that's really, really painful. Yeah. I can type as usual. Right. You're familiar with process and from looking at your own process IDs. So as have an end you can see. Right. So if you're root on the host, you'll be able to see everybody's processes and the namespaces attached to those processes and all the way down. If I start a second shell and run that one inside of a namespace, that shell will only be able to see whatever it has and below. Like we looked at that a second ago with which processes are there, which mounts are there, right? If I do the same thing with a process and start creating children in it, the root will be able to see all of those. And if I were to look at the specific PID, you can actually look at an individual process's namespaces. So if I do, let's block, right? Let's pick 1220, 122.85. 122.85. NS. So yeah. I can type sudo, can't I? And you'll see that's got a significant chunk of things in here. If we were to say, yeah, I'm just gonna make this easier on myself. 122.85 NS. Yep. Yeah, it's a fun joy to house this thing. Yeah. So that one does have a super and it goes up there, but yeah. True. Out of habit. Yeah, and then you get the fun joys of how do you jump around in these things. I guess the question is, should I just go ahead and ns-enter into something random? Actually, should figure out what process that is first. What's the likelihood I did that? That's not that one. I think it's a different one. I probably do not want to kill that particular shooter command. See here. Find. I'm trying to remember the find command to literally search for a file's content specifically underneath. And it's not a pretty one. Also even harder to do it. I guess don't have to. Let's see here. Now it's 1, 5, 2. You know what? Shell in there right now. Okay. Bracket page up. Yes, that, and this. Planning. But if you look at the rest of the processes, you can see that the page sets are entirely different. And the user namespaces are supposed to be different. Yeah. UTS is set up different. Okay, so I should tell you what UTS is. And this is actually one of the, in this one in particular, it's like, what? UTS. So when you have different namespaces, this is how your container is. Right? So if I were to go into one of these containers, they would actually be labeled like one or CNG web server. Their PIDs for their children are distinctively different. Their PIDs are ever so slightly different, and if I were to look under that namespace, with that process namespace, I could then examine everything that's actually inside of their PID standpoint. if I look at their mounts, you notice their mounts, right? They're different. But if I go into those Docker containers, yeah, here's time service. Unix time service. Yeah. Yeah. So if I were to pull up the specific of what it is, it's one of those things where the name doesn't make sense at first. You're like, what? But not time service. How your host names are. There is actually a separate way to control it. I was crossing the boundary on those two. I apologize. So let's just Google here. Why do NS enter? Now, that's why I was like, it says I'm, process. Inside of that. Obviously, if I'm root on my machine, I see all of them. You're right. That's a typo. That does actually see a bunch of things. I'd have to actually mount. Okay. Working on slides, and this is not a plan to execute. So what? Right? I don't know. collect your host name, ask the current is my the, with a, the hey, no problem. Yeah. Come on. I'm still in the container, no wonder. A container does not need manual. Maybe. Yes. So the short answer is PS1 is actually controlled through an environment variable. So you'd have to somehow set the environment variable as you went into the container to ensure that depends on what command you executed. So if you literally did what I did, which was bin bash, I mean, in theory, you get the bash RC. But the only way that you would specifically know is if you actually, you can, because you can actually ask proc. There's some information in procfs and sysfs that will actually tell you that you're inside of a container. Yeah. And that was my fault because I wasn't paying attention, so I didn't realize which thing I was trying to run. Right, and it's a really good idea, is having your PS1 actually show something different, especially if you're working with anything that could be production. Having your PS1 be like, yeah, don't be an idiot, please. But you, yes, in theory it could. But put entry into a shell RC that would detect am I in a container. But then you'd have to put it into the for that. Yeah. That's what I needed. I needed tech U when I ran that nsenter command, and then it would have. So if I go back up to the nsenter, tech U, blah. And now it will actually be paying attention. I'll actually do that in. This is all the manual. The fun of exploring command. Can you tell I don't use nsenter on a Now I go back to so that in short, basically you can have all the mounts. You can have some of the mounts or specific things. If you really wanted to get weird, you could enter into a bash shell that only has namespaces from container. I'm still air quoting container because container is not really, it's a thing in itself. It's a bunch of things that come together. Right? So if you wanted to operate within that container and be able to interact with the network as it sees, you could pull in just the network namespace. And the IP commands, you'll see it as if you're inside the container. But when you run PS commands, nope. You'll see a bunch of other stuff. I'm going to cover more in a second. Short answer is that effectively namespaces in the kernel are the building block on which containers that C groups to actually control, say, I want you, or I'm only allowed to. You can even from the BA. And you specifically want to say, I never want this container to ever run more than 4 processes, you can literally say, once it goes through them, it will be denied and be able to start the process. Yeah. It can be very interesting. It also can be very dangerous to play with. Yep. Will limit processes is to prevent somebody from fork bombing you. Yeah, so nope. Pop. It does not like you violate. So there's good. Effective, which is for scheduling ability, and resource limits, the prioritization, like nice level, right? You can have a separate nice level for a process. You can have a separate nice level for an entire process. So namespace allows you to set. You can say it's only allowed to ever have, and on top, only ever allowed. So you can handle prioritization higher C group. Control on high, and it's you can't do anything else. So even if you have the concern of, oh, I have too much stuff on it, kubelet still has priority over everybody. Because kubelet can, I got a slice in there because and just tell it. Actually not. Because of C groups. Now we can do that for accounting. Everybody likes this. For example, you know exactly what has and what level and where and all this. And control, like I said, all the craziness things that you can do to a process that you would normally do. these items. Already under. So C groups allow you to literally slice the machine up without slicing it and hard. You can set maximum amounts or hard reservations. Say, for example, I want this process to always get at least 256 meg of RAM. I want it to have up to just cap. If it ever goes over a gig, RAM because that's a great constraint for memory. You can also say that then you can do that the same thing for CPU. Now with memory, if you go over the limit, it will be killed by the memory killer in the kernel. Period. The CPU, you instead are just throttled because you have to occupy that much. Period. Really, let me get it. C groups does the same thing on the C. Script, but constraint. Same thing with network. You only so much throughput. I want you to choke out the rest of the processes, even though I know you're moving you can say that. Let's see. Interpret all that and the things that we kind of poked around that. This comment. I can say nope. It's actually the processing. That maybe look with how But with layers, and this matters because I say lots of layers. If you have a lot of layers in one Docker container, you're actually going to have problems. So our options here are AOFS. You have overlay, which unless you're on Red Hat, then just DevMapper. You switch to overlay. AOFS is the DevMapper doesn't, but it actually uses the kernel APIs to deal with that. Unit. If I were to go into that directory, I could actually go to the command and I did this, you'll find like 3 at most. Maybe big difference there. So if I really do that, if I were to do this, I need to express that process. Find it. This can be different, right? You can actually do what we're doing on one screen. This is where you have that difference in terms of complexity of the room. 50 bucks is absolutely fine. Die. But down one side, you can see the layers that are actually in there and what the effects are. On the other side, you actually examine that particular layer. So, whiteout, like you remove the file, it's a whiteout. You alter the file, you can actually see that file was actually altered, including any permissions. Okay? You know what? Permission changes. Don't see it group after adding a data data. Don't do that. You see it group and then you copy it into the container. Because every single time you change a file attribute, it's a difference in the file according to one file system. If you add a data and then you see it group or you've shown it, you've modified a data and you have 2 layers that are different each. Yeah. Use runtime or turn off time. Yeah. Anyway. So that's and like I said, if I were to actually go up to that work there, oh right, there's not really a whole lot. We have spam. And inspect. Raw. Here's another tool. It's actually from Red. Yeah. Works. These are actually they didn't like, but it's a container is manifest contains more stuff, and a multi-container manifest like that, a tag refers. You have to go into that and then the details. You can see the size. The size is your compressed size. This is not your decompressed size. So that's a gzip tarball size. The remember when I said we need to make sure that we can guarantee it? Because we have the digest, we know that the file that we download from wherever that is actually stored will match that SHA. If it doesn't, we're going to try again from wherever our sources are until we actually get it. We're doing the same thing. Would see many more layers. Because we have a base image, it's based on Debian, and then we install some packages, and then we comment, and then we install 8 layers. Like, you'd actually have one for every single one of those. If I were to manually download that layer, I would actually get that diff tarball out. Like I said, when you of course we had tarballs, right? No, I showed you BusyBox. It's one layer. Really BusyBox in a container. Splat. One of mine, it would be a whole bunch. Well, to make sure they actually put in that I just showed you where that layers item was, that actually is indeed an indexed array that will be sent in the code. At that point, now that this is going to be what I get. Matters. We actually make actually pass. Would get we had an entry point script. The first thing it did was apt-get installed. And then did I mention what time I did the slide? It's mental breakdown. Period. This as probably a little bit. I so. See, all I saw was ice cream, and I'm like, I need sweet. Yep.
Hello? Bueller? Yep, that's me. So it's showing on the mixer board, but it's not coming out back there, Jeremy.
Can we switch the left output?
Switching the output now. Hello? Bueller? Hello? Me? Turn me up. Turn me up. I want to go louder.
Put back to aux.
These things are so complicated.
Pre and post.
I don't know. You're pointing at things like you know what you're doing. That's good. I don't have a clue. Anybody? Anyone? Anyone? How many engineers does it take? Now, anyone? Anyone? No? Still not? Anything?
Are you on back there?
Yes, but I don't know if I'm specifically on the right mode.
Oh,
Yes.
there we are. That was the right button. Definitely. All right. Now they can hear you.
Oh, does anybody have a problem hearing me? In the back well?
I don't know.
The stream heard you perfectly clear. Okay.
Stream. Stream.
Switch over the mic, and that is way too loud. I need to know I gotta whisper. Rechecking volume. It's not screaming at anybody. It's not picking up the mic. Feedback. Good. Okay. That reasonable? Not yelling at anybody? Okay. Back row can still hear me. We're good. All right. So, doop. This one is more of a hands-on session because we finally wanted to get to that period in time. So if I go to open a new window, I'm on session 3. Come on. And now I'm looking at session 3 that has all the wrong content. What the? And my slides were deleted. Okay. That's quaint. Okay, so what the slides said, since apparently I don't have them anymore. So now that we actually know what containers are and what the components actually make the things, right? And I apologize if that was the boring part, and it may have been for the stream. Too bad. You now know actually what they are and how they work, so you can take that and do something of use with it. So the first thing we're going to do is actually look at the most common form, which is a Docker file. Right. The idea at this point is to actually build them right, and then deploy them and run them, and look at a few cases where built well, not built well, or built overly complex. So now I'm going to try to find all the links that I had earlier. And my mouse stopped working. Okay, great. So everybody's familiar with the very simple basics, right? What a Docker file is? Yeah? Okay. So let me get over to that. CNG. So a Docker file is effectively a way to tell Docker to actually build. It's a scripted set of steps to build a Docker container. I say Docker container because their syntax is a little different. They use Docker files, and then they have a series of commands that are relatively well documented in docs.docker.com underneath the build. This happens to be one of ours. This is actually the version of it from the 15.0.0 last month. So what I have here is actually a very complex image. Let me get... Do I have base in here yet? No. This is a much simpler one. Okay. So every Docker file effectively has primary things that you want to care about. It has, where's my mouse? From, and what this is basically saying is you say from and then an image name and either a tag or a SHA, as we talked about before. There's a SHA on the file system, there's a SHA on the manifest version, so you can refer to them by an explicit version. Most people use a tag. That one in particular, from thing as compile. Now, everything from that from line down until another from line occurs is going to be operating within whatever that container is. Here, from image is actually just our Go container that has our specifically built patched version of Go. Compliance. The args that you see here, args can be passed when you run Docker build. It basically allows you to do a build time argument for whatever your Docker file is doing and use that as an environment variable in the commands that we will later use for run. In this particular case, we're building environment out from arg. It's our way of having an easy way to tell it what version of the software to go build. We'll create one from scratch, a new Docker file, and actually go do things with it here in a little bit. The next things that we're going to care about, we have from, and then we have runs. This one I want you to pay attention to because this one most people get wrong. You either have a huge number of runs, or you have a run that has a huge number of things in it that makes it hard to follow. One of the things we care about is that these run statements, when you're done with every single one of these, whether it's arg or env or run or copy, that's a new layer. Right? And that's why we talked about how layers are composed in tarball. If I do run and I chown things after I have a copy, if I copy in a gig of crap, and then I run chown / root, it'll touch everything that's not already root. Every single one of those is a new file on a new layer. Then we have, later on we see this extra from at the end. Right? I'm running a series of commands. That's a layer, and then there's 3 here, and then this from scratch. From scratch is actually special, and this is what I want to point out. It's actually good I picked this file. The from scratch literally says, give me a bare file system. And I mean bare. There's nothing in it. Scratch. All I do in that container, which is the output from this completed Docker file, is copy the compiled binary into the container. It's straightforward. I literally go, I say up at the top, from our Go binary as compile, so I can reference it later from the copy command. I set the URL, I copy in the scripts, and then I actually have 3 commands. One that actually pulls in all the dependencies. That one does apt-get install. The download actually goes and pulls the source and verifies that the source is what I told it to be. Its SHA matches, its signature matches, and then it builds it. It's just literally the effective make.
So it's kind of like you make like an ephemeral container with your build system. You build it, and then you turn that output into the actual container you're going to use.
Exactly. And exactly what we're doing. This is actually slightly advanced, but it's not that advanced, in that I'm showing you a Docker file that is a multi-stage build. So I'm very intentionally going, build the thing I care about, and then give me just the thing I care about. Because if I install the entire development toolchain into my container and then build an image, do I need the development toolchain anymore? Right? Now, remember we talked about where layers are all of the changes that you made. If you do run install dependencies, apt-get or pacman or whatever, and you base devel, right? And then compile your program, and then you have a run later that does apt-get uninstall. Guess what? You have a layer that has all of your actual base devel, and then you have a layer that's the result of the compile, and then you have another layer that is the result of removing all the packages. So you're shipping all 3 of those. You don't want to do that. Well, there's ways around it, and I'll touch that in a second. But if you use multi-stage, which is to do the build and then just do the part you care about, your output is only what you need. In this case, I have a 1-layer container that has a single Go binary. This one is a good example of how to make sure you only have the right output in your container. Probably not the one I should have started with, though. Question in the back.
That you've done bad things like that, because it's kind of hidden if you just look at it. You wouldn't realize that you messed up really bad.
Yes, and I will actually show you that in a minute. So remember I tried to show you dive earlier? Dive is super handy in that regard, and I'll show you that once I get a chance, okay? Now, if I go back to this giant one, right? This is the one I pulled up. This is actually an operational container. This is our like SRE toolbox in the deployment. This thing has one of these in it. I say one of these because it's a giant run statement. Now, this one in particular, you'll see there's a whole bunch of copies. We're pulling in all the bits of Python. I do wish that was cleaner, but that's technical debt. The run here is effectively a run-on, right? So anybody ever written a bash script has seen a line like this minus the continuation lines and run at the top of it, right? We're literally just chaining commands back to back to back to back to back to back to back. And the indentation could be better, to say the least, right? Now, I have get update, and I have get install at the top, and right at the bottom, I have remove. That is how you get around the problem of your toolchain is installed, is to have a layer that actually does this, of install it, do the thing, get rid of it, all at the same time. That's it. Note I said get around, not do it right. Right? Now the beauty is I get to use my own code as examples of good and bad. Right?
As an example of
Good and bad. So the last container showed you multi-stage builds and actually only getting the output you care about and having clean and straightforward methods. This one, well, I can read it. I should be able to. I wrote it, right? But we have the problem of like what got done where, what actually was the result of this. Basically, I did pip install and then got rid of GCC because I needed GCC because of some Python extensions. That's effectively what I just did. Like, okay. Well, let me see here. So I'm going to have to decrease the font size. I apologize. Docker images grep toolbox. I don't think I have that. Let's see. Dive. I did not do that entirely right from memory. Did I? Typo. Of course, that's going to take a minute. Now, the upside is, you see how all of those layers say already exist? Right? This container shares a base image with some of the images that were already on this machine. So when we went looking for the Ruby and Gitly processes earlier, right, through the NSNR stuff, they actually share commonality until that point of already exists. And then these are additional layers after that image. So this particular container is based upon the GitLab Rails container, just like our Workhorse and Puma are. The Puma process that we looked at, which is, it shows up as the the web service container, it actually has the wrapper scripts to fire up the Puma process, which is the Rails server. This machine is based on that because it needs the same code around. So it actually shares all of those previous layers with it. So I only had to pull the additional layers that this one uses that the other one did not have.
Does it catch them for other things so that other ones like use the same stuff that this one had to pull it the first time? Subsequent ones get them for free?
Yeah, so the question for the crowd was, does it cache them on those shared layers so that new pulls automatically get those? The answer is yes. Right? So the thing is, a tarball for a layer is very much the same as something for Git. Once you've Git pulled, if you check out a branch, unless you say like depth 1 when you do a Git pull, it's going to have all the other objects. So it doesn't have to go and pull the other things. For Docker container, it's pulled that tarball and it has an object SHA. So the layer has a name by a blob and a SHA, and the image has a name by a blob and a SHA. If your layers across multiple image or container definitions share the blob, and you've already pulled those shared layers from another image, then the blob already exists on the file system. So they'll automatically share. Now, that does not mean that they share magically across nodes. Right, so if I pull it and then you pull it, even though we're on the same network, we're separately going to pull it. But if I pull web service and then I pull toolbox, 3/4 of the image is already down because they share the same base image. Okay, so this one has a giant pile. I have to go even smaller so you can see the whole UI. Oh, wow. So can we still read that? No. Yeah. The good news is everybody's about to know if they need to go see their ophthalmologist real fast. But so it's really hard to see from the back. But what we end up seeing here is Dive will pull the image and then look at it from the perspective of decompressed bits. So this actually says that the total image size is 1.6 gigs. Yes, that's massive. However, it says the potential wasted space is approximately 17 megs. Wasted space is an instance where you're modifying something but then not really using it, or you're creating it and then turning around and deleting it later. In my case, that's like the apt-get log is being changed a couple of times. So you can have a giant pile of wasted space if you say copy stuff in and then chown it and then do something else afterwards, because now you've got like a gig's worth of junk.
Is there a linter or something that like suggests fixes or whatever? That kind of stuff?
Yeah, so the slide that got deleted was like, these are the tools we're going to talk about. Docker Scopio, which I used Scopio earlier to do the remote inspection. Here is Dive, although barely legible in this resolution. And then what you're looking for in terms of linter, right? So Dive actually has a CI mode that will tell you some of this stuff like possible wasted space, how big the images are, how many layers are involved, that you can set, oh, there's too many layers on this image, or there's too much wasted space, or the image is just too darn big, which at 1.6 gigs, maybe I should do that. I have reasons, don't worry. How to lint will actually lint the Docker file itself, and it will try and catch some of those things in the Docker file. But clearly, it doesn't have information into the lower file systems. It only reads the Docker file, not what the renders commands will actually do inside of the image. So we'll get back to that. Now, what I have on the left-hand side is this very top one that's 80. Better? 80 megabytes. That's the Debian Bullseye Slim. Okay, so it's the minimized version of Debian Bullseye in the smallest container they can get within reason. And then there's the giant pile of stuff installed. And as I scroll down, as it catches up, I think I held the down arrow too long. There we go. It will actually tell me on the right-hand side, if I switch over to it, all the files that are involved on that particular layer. Now, the nifty part is, if I do Control U, remove anything that's not modified. That's not the right. Not being able to see the full UI is driving me slightly bonkers. Yes, I do wish it scaled better. I just don't know what that resolution is, but it's not very high. What's Control U? Unmodified, yeah. We go back to another layer that does actually modify things. There we go, there's a highlight. If I take out all the unmodified stuff, greens are additions. If I take out all the added stuff, it doesn't have the modifieds anymore. There we go. And yes, you can collapse, thank God. You can use dive basically to walk through and find out where the adds are. And because it does give you some amount of sizing information, if you add a large directory of something, you can actually go and see where those were at. First off, the size of the changes on a per layer basis. And second off, you can actually hunt down where they came from. Because perhaps you're literally just doing make. Right? If you're doing make and it's some large project and that make just spews all over your file system, you can go hunt down where it did it and from there have an idea of what things you need to change in terms of your configuration or what the final binaries you actually care about from the make are so that you are then later doing an install to a directory instead of leaving all the junk behind. And we've had that our own way. We compiled Giddily and left the entirety of the tree there, including all of the Godur's cache. That image was a couple of 100 megs too big because we forgot to remove a directory. It's that way for like 2 months. Yeah, it happens. So, this is my giant one, right? Now, if I do this if I were to literally pull Debian Bullseye Slim, it would literally have one right there, maybe two. Bullseye we saw earlier when we looked at the layer count, it had one layer, right? If I go over and I'm going to go up to, tab again, roughly 5 up. Here we go. You see this layer is not very complicated. We changed a few things, but not a lot. That's actually, I believe, a chown. I have to go look at which particular layer that is. It's a whole bunch of environment variables, so it's almost impossible to read. Yeah. The command down here, by the way, it does actually tell you what that layer's command was to produce it. It's just that it's complicated enough that you can't read it. See if I can find a layer that I can actually read. No, I don't think I'm going to find a layer I can actually read. That image is just too complicated. Okay. Now, see if I can get a simpler This doing the twisted head is killing me. I apologize. You know what? While I'm there, why don't I go ahead and answer that question in terms of, like, can I scan it for stuff or lint it? Right? Lint. Now I'm having trouble reading at an angle. I really should be sitting down there. It's complaining that I have multiple consecutive runs consider consolidation. Now, this warning is straightforward. You'll see this a lot, by the way. So, in this case, because I'm doing a multi-stage image, it's not really a problem because the final from is the one that'll come out. But what it's saying is because there are lines like run, 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 right? So in that one, there's run dependencies, run, download, run, build, and then right back to back to back. A lot of the times they'll suggest that you do that all at once, like we have in the toolbox container, so that you get one layer out. Because remember I said every single one of those commands is a layer? Because I'm using multi-stage image, I do all those layers, and it doesn't matter because it's going to get discarded immediately. Because that final from will produce just the output. Whereas if I have another container that actually has run, 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 run back to back. So if I do this, but instead of that, I go ahead and do toolbox. That's going to give me a little bit more of a warning. And there's a bunch of things it probably doesn't like. Always tag the version of an image explicitly. It probably does not love the way I'm using parameters to set what the from image from is. The pin versions in app to get an install, that's actually smart depending on how you're doing things. Most package managers, you can say, I want this package and I want this package at this version. Well, the downside is you don't automatically get updates if you're doing it from a trusted source. The other way is, if you're not sure it's a trusted source, you should probably control your versions, right? So, for example, if you didn't want to get the latest version of Python, you explicitly wanted to get 3.7.2, and your distribution upgraded to 3.7.5, and there's something in your code that just doesn't behave right anymore, you can say apt-get install Python equals version, and you would get exactly that specific version. They're saying this from a recommendation standpoint because if you're doing installing of packages, you need to know what you have, or at least have a way to verify that that is the one you actually want. Because if somebody changes your repositories or gets in between, what do you get? Right? Use trusted repositories, use signed repositories, and when appropriate, pin your versions. That's what that warning means. Avoid the use of cache directory with pip. That's cute because it specifically caught that I'm using Python to install Python packages, and it's saying don't use cache, right? Now, remember I mentioned earlier we built Giddily for a long time and we left the Go cache around. It was several hundred megs. Well, if you're installing a very large amount of Python, you'd basically do the exact same thing. Hence, turn off the cache directory if it uses pip. Now, these rules are, you can bypass them. You can tell them to ignore certain ones, but I'm not going to go into that in specific detail. The next one we have is, watch out for the mic, sorry. Yeah, and then, of course, pin version on pips as well. Right? If you're using a package manager of any kind, pin the versions if you have a way to pin the versions. That's basically what it's telling me. Now, we know exactly which versions are actually there because we do an interrupt cache. Long story short on how infrastructure works. But we don't pin them in the Docker file itself. But this says we should probably go back, revisit that, and consider doing so. Now, that's the much more complex. Like if I were to diff the two files side by side, or just look at the two files side by side, really, you'd see like one is really tiny and one is ridiculously long. Right? We just did look at them. So with the multi-stage, you had run on small commands that are basically just scripts that take environment variables and do their thing. Whereas on the toolbox, you had that giant run command. Now, if I had that run command making up like 15 run commands, could you imagine generating 15 layers? Yes, the image actually is like 15 layers, but I didn't generate them all in that Docker file. Okay? Now, the question that I'm going to actually pose to everybody here is, do we want to walk through building a couple of Docker containers? It is 3:46. We have time to do one or two.
When you say build, you got actually like the one from scratch?
Yeah. Like we'll just like figure out what it is. Yeah, work on it. Yeah. So the sheer answer is how many people have actually done Docker containers before? Okay. Who's done complex Docker containers meant for production? One person. Okay. So when you do a Docker file, here's the question. Do you do from Python? Right? So from Python 3 or whatever, and then just go from there? Think about that. When you're building these containers, what is in them? Where do they come from? Right? So let's say, for example, if I do dive on Python 3. So 3 is a pointer. Every tag is a pointer, but 3 in particular is a pointer to whatever the latest version of Python 3 is. I'm going to run this, and I'm going to see what it was built on. I'm going to see how many layers are already there. But I'm not necessarily going to see the name of the images it came from. I have to go to the repository to find out what those are. Hence dive says like from weird hash. I can help you with that in a second. That's kind of on the advanced side, but I can show you. Of course, apparently I'm waiting for downloads, so while that continues.
Could you show how you did the removing the app list again?
Say again?
In your Docker file, you had a line where you were removing the app list. And when
Oh.
I paddled in on a Docker file I had, it told me to remove the app list.
Correct. So the removing of the app lists you don't generally actually have to do depending on the version of the container.
Okay. So
Um,
if I did like Debian Slim, which I just changed over to,
yes.
it complains.
Yes. Okay. So that's a great point. Some of the distributions, while we're waiting for this to pull down, so I can give you an example. Debian, as an example, Debian and Ubuntu both now actually tell you stop removing the app lists. You want them removed. However, when they build their base containers, the tarballs that go into their base containers, they preemptively patch it so that when you run apt, it actually removes them afterwards. So because so many people literally had extra lines to go remove the app list, and it's the biggest mistake that was being made to just leave the package cache alone. You just build a new image, install GCC, and now you have like 15 packages in cache that you've got to remove or forget about, right? They actually went in and added the hook to the command so that it automatically cleans out. That's why you've got the warning about, hey, you can take out that removing app lists.
Okay. Makes sense.
Yeah. They decided to help everybody in the community just be like, you know what, we're just going to make this as default, and now everybody's images are a little bit smaller, a little bit easier, right? Okay, so here's Python, like the actual official upstream Python container. It's, 920 megs, so it's kind of big, but it's also all of Python plus the OS, right? Did you know Python was that big? you do. So we have from on the base container, which if I go in here and I go into etc. Anybody remember how to find out what exactly you're in? There is a file in etc. It's a LSB release. This is definitively a Debian base of some kind. Whether it's Debian or Ubuntu, it's probably Ubuntu to be fair. Then you'll know where that is. Now, you have to open the actual container or run the container and go check the content of that file to be 100% sure. But this is how you can very quickly go and see where things are. So they run apt-get update and apt-get install a bunch of things. And then they have something that's going on here. An interesting piece here is, see this command for GPG? They're actually saying, is GPG present? So if I were to go to the Docker file for this one, they're actually doing something only if GPG is actually present. So they're doing, code signature verification or things like this. Then you do an install. The no recommends there. This is one you're going to care about. No recommends basically says don't install extraneous packages that I think you should use. Only install the stuff I actually require. Now, I don't love the here's an apt-get install, here's an apt-get install, here's an apt-get install. But I'm sure they have good reason, and they're probably smaller layers. You have 124 megs for the base, which is why I think it's probably in Ubuntu. A couple of small changes, and then 152 megs, so they installed a bunch of things. 529 megs. I will bet you that's build and install Python. 18 megs here for another apt-get install, and then nope, there's the get Python, so there's that. Maybe that's the entire dev chain. And then they're doing something to the directories. Unfortunately, I can't scroll sideways. I could see more if I shrunk this even farther, but we'd all be entirely blind, so we'll skip that. But what you basically have is, here's the total thing going on, here's the total size, and you can see where it's all coming from. Like, if you need Python from a runtime only perspective, you probably don't need a 900 meg image. But if you're building and installing Python, which may include C libraries and other things, you probably need that at least for one of your build stages in a multi-stage container. Okay. So, what do we want to build a container of? Yeah, what do we want to build a container of? We're going to build one container.
I was going to ask another question, doesn't have to be now, just as root user, is it possible? I know it's possible. You create this virtual, perform your task, and you've got your auto remove virtual machine's gone, or namespace is gone. Can some function monitor that and tell what happened, keep a history of what happened? This namespace was created, this code was executed, namespace disappeared.
Let's have that discussion at the end of the day.
This is not a question for right now.
Okay. So let's say that you want to build a new container that's got what? Nginx in it? Right? Sure, there's an Nginx container. Right? There's an official one. So let's do the simple. So for Docker or many other places, there's multiple locations that have pre-made containers. The most common one is on Docker Hub. So to be fair, the Docker client assumes that if you don't provide it a host name, that you're talking about Docker Hub. that being said, there's also Red Hat hosts and maintains k8s.io. And you also have any GitLab instance that you might have. Your company may have a Harbor instance, or I think JFrog has an Artifactory plugin that does a container registry. This all comes down to like what the image's name is, right? Images, when we refer to a name of a Docker container, it's literally just a name and a tag. They're made up, right? It's a manifest that has this name. Inside of that is a checksum and a SHA, and a checksum and a SHA, and then it has pointers to other checksums and SHAs, which has pointers to other, right? The whole system, like I said, very, very much behaves similar to Git, or a deduplicated file system, hence the shared layers. The way you end up squirrel. The way that, yeah, nope, my train of thought just went right out the window. I apologize. Completely lost it. Images and tags. When you do a Docker build, one of the arguments that you can pass is a -t or tag, and you provide it with a name. The name actually includes the host and the repository that you want it to be at, and then a colon and then a tag. If you don't provide colon tag, it will actually just add latest. The build process does that. If you do not provide a host name in the name, it assumes that if you try and push it, you might be trying to push it to hub.docker.com. But in reality, I can take the same image down and I can retag it and push it to my registry. It's the exact same image, but it has a new name and a new tag. They're all just pointers. So, here's the one. This is their page for it. Now, if I were to go find where the Docker file is, the UI used to have a click for where the Docker files were at. I'm going to go to their repository because they probably have the Docker file in here. So here's the Docker Debian, right? This is their template. And you can see we've got a from Debian, right? And they're specifically always try and build from the slim version, so the reduced version. Let's see, do they have any more froms on the line? Okay, that's a whole lot of a single run statement. Okay, nope, so they basically go straight from that, and then I don't see another from anywhere. Now, remember I made that mention of the giant bash scripts inside of a single run? Hey look, there's another one. Now, I'm going to call this one out. This will result in the smallest possible image. How much fun do you think that is to maintain? Because the indentation is actually semi-sensitive. So maintaining that giant list in a single run is going to be an absolute pain in the butt. But they do, this is my base image. Here's a label, which basically is literally just a label on the image. It's contained in the metadata. And then we go down into a couple environment variables that you can pass. And then the giant run statement, which goes and builds it, pulls in the plugins, installs all the requirements, and goes forward from there. Right? This is a simple container, per se. Right? So if I do, dive nginx latest, it's going to be relatively small. But to edit that bash script, you're going to be best off to actually take the file, cut the run off the front, edit the bash script without all the new line continuations, and then put all the new line continuations back on it, and then stick it back with run.
So is there a minify tool that
A minify tool won't fix that problem because it's just one giant run-on bash script. So that's the downside. So I could go and I could effectively build the same thing. The other thing is I can say, I don't want to build it. I want to actually have a container, which is Debian's Nginx. Right? That would be the simpler way, rather than building Nginx from scratch. Okay? First thing I'm going to do, I can do Buster Slim, but let's not do that. Okay, and then run. Right? Oh yeah, look at that, I can type. I am going to ruin the presentation. That's what I'm going to do. Like I told you, I lost my slides for whatever reason. I'm like, really? It ate the slides? Okay, you do the apt-get update. Remember, this is one giant run-on. Did I spell that? Yeah. No recommends, because I don't want everything else. So that's just go install, right? If I do just that, then in theory, I should have just the container that's Debian with Nginx installed. Relatively straightforward, right? But here's the question. What's it going to run if I run it? Exposing ports, the first thing you said was right. I said, what's it going to run if I actually do Docker run? It's going to run whatever Debian told it to run. Because if I install Nginx and I don't tell it what to do for the container, I don't tell it the command, I don't tell it its entry point. For example, if I didn't tell it, hey, please run Nginx as the default process. Now, I notice I didn't say PID1, I said the default process. Because you can override the command in Docker at the runtime. So if you do docker exec ti thing bash, that overrides the cmd for the command. The entry point is what it will always use. So there's Nginx. Now, anybody remind me the path of Nginx and Debian? I don't remember the binary location. So let's just cheat. Into path not built. I'm going to say I want it to, here's the context was in the location that I'm already in. Build, right? Straightforward and simple. I'm not going to bother telling it what tag, and it's just going to spit me out a hash at the bottom when the internet continues to work. Did I type something? It's not understood. Probably the order of operations was mad. That's fine. White space in bash is okay. It just ignores it. However, I've hit vim twice, so I need to go up until I actually get to Docker build. Okay. So all we're going to do is basically have Debian with Nginx installed. Absolutely nothing special, right? But if you're, all you need is the known version of Nginx from a distribution you trust, this will work.
No dash install, dash recommend.
Nah. Yes, no dash install, dash recommends. Okay, everybody on the live stream laugh at the guy on the stage. First, it's hard to do it in this direction. Second off, yeah, more coffee. What? Hey, look at that. Cool. Because I need tac Y.
Yeah, nobody else told you about it. We all watched you do it.
Congratulations. This is what will happen to you the first time you do it too. I'm not sure this is how you debug a Docker file. This is how you hack it in your face, but. Note to self, actually pass all the options. Not like that, thank you. I know there's an extra space. Oh, come on. I hit escape. Yes, Vim haters, blah, blah, blah. You have to hit escape, I know. And yes, by the way, because it's a new container, it has to go update the package lists every time. Because remember, the file systems aren't shared. It goes away. It's doing an update every single time. Okay. So the question was, if you wanted to change the configuration for Nginx and include it in the container, right? So that when you run the container elsewhere, the configuration is included. There are a multitude of ways to do this. The most common way is to, yes, make a static change to the configuration file and literally do a copy from the version you have outside to the version you have inside. Or maybe you're just setting one line, right? If you're setting one line, you can do that as a part of a run. If you're actually making larger changes, you can do that and actually have a copy of the nginx.conf and set it how you want it, and then just copy it into the final destination. So you have a layer with just nginx conf in it, as an example. But a more complex and common pattern is to actually make nginx conf a template, and then you actually render the template when the container starts. Okay, so that's a. Where did I put the mic?
Sit over there by the vendor.
Maybe. I can't tell. I can't see it. So. Okay. Just because that's a more complex question, but I'm gonna let you re-ask that in a second. Okay. So touching back to this for a second while we test the mic and confirm. This successfully built. You'll see it says it's just on gibberish numbers. That's a SHA down there. If I wanted to. No, they're sharing. Okay, well, we're going to try. Let me finish this statement, and I'll come back to your question in regards to, like, remote updates. If I actually wanted to tag this, right, I could have run docker build -t and then something /nginx line, right? And it would effectively just do that. Right? It would build it and tag it, right? Now, you'll see that this actually says I've already done all this stuff because I'm in the same working directory. And it realizes that, like, it's already completed and nobody has changed anything. If I were to take this and go docker tag as nginx, I spell that? Now, if I do docker images grep nginx, you'll notice I've got the nginx container, which is the official one that they have, and then you have something /nginx and something else tagged with nginx. If you look to the right, the images SHAs are actually the same. That's what I wanted to try and prove real quick. It's the same image underlying, it's just a new name on it. Okay? Alright, so to the question on Unify. If you wanted to have a configuration change and somebody remotely set like the version of Unify and there's a new version out. Now, did you want to install the new version of the Unify package or like go pull a new version of the Unify container? So here's the fun one. We'll get to that, and that's about using the containers and deploying the containers, less about building the containers. So the question is, if you pull a new container of the version, or version of the container, will that wipe out the data? Yes, it will, if your data was still inside the container instead of inside of a volume. So what you actually do is tell Docker, I want you to mount this here, and whether it's a file system or you can actually create a Docker volume that's not local to your file system, but is a separate image layer that will pull in. Remember, we talked about the layers and I showed you where it was on the file system. You can have actual mount this directory from the host in, or you can say Docker create volume name and then say Docker volume name colon and then path to the inside of your container. Then your data is not actually in the container, it's actually in this other writable volume. So when you update your container and you pass the exact same arguments, you get all your data in right away. Mm-hmm. Okay, complex question, and I'm going to want to jump to the BuzzCrate stuff here shortly. The short answer is not natively. So it can be done, but you can't do it natively within Docker or Dockerfile itself. Okay, back to where we were. Right, so this is all we've got at this point. If I add in one more thing, which is your nginx conf, yeah, there. Notice it highlights it when you type it right. If I were to actually copy this into it, etc. nginx conf, I think is the path on Debian. G. In the end, I'm not going to build the container. So effectively, it says copy this from the working directory or the path in the working directory into the container at this path. Because I didn't say copy from like we saw earlier where I was copying a binary from one stage into another stage. This one is actually saying pull it from the build context and then put it into this location. Okay? So like this would be what you would want to do if you wanted to statically override nginx configuration as an example. So like we actually have an example as part of BuzzCrate where you just install nginx and then you overwrite the configuration file and then you mount in it's a config map in Kubernetes and it basically has the contents of an HTML file. And you just go edit the config map and the container goes, oh, there's new content. And it takes a couple of seconds and it just updates that HTML file. Now mind you, the HTML file is 5 lines long, but things like that. So we'll get back to that, but effectively you can just copy in that regard and you can mount files in through volumes to address a couple of things. So if I were to actually declare and I would say volume, and then I would actually tell you where the volume is supposed to end up. All right. And that's, I don't want to get too deep in the weeds of actually doing a Docker file itself. All right. So this has been distracting for me because I don't have my slides, and I apologize. Effectively, though, what you end up having is this is how you build a reasonable Docker file. And how to lint will give you a lot of good hints, but sometimes they're not practical. The Docker files, in the end, you need to be able to read them, and two, you want your output to be as small as possible. So reducing the number of layers is key, but also knowing what's in your layers. Dive will help you look into the details of what's in your layers individually and where the size of those come from. How2lint will help you produce better content in your Docker files. The last thing I want to point out is when we looked at Python, and we're like, okay, well, that looks like it's probably Debian or Ubuntu, and like, here's the stuff. And then we looked at Nginx's stuff. When I say, okay, but what's Python? What's in Python, right? You need to know, if you're building on top of somebody else's image, you need to know what else is below it. Why does this matter? Very simply. Where did your code come from? What is the chain of trust? Right? There's a reason they call them supply chain attacks. You do not want to deploy something into production that you don't know where it came from. It's just not a great idea. If you can keep your layers small, build exactly what you need. I actually would generally advocate that you not build off of somebody else's language runtime base image, but instead have your preferred distribution, install the runtime from that, and or build it yourself, and then install just the runtime and your code. Because you'll have a smaller container, you have a smaller footprint, and you have less attack surface. And you know where it came from. And 90% of it's signed.
90% of it is signed.
Package repositories and their metadata from official repositories from the distributions are almost always GPG signed. And if they aren't, you can usually convince a company that's producing packages such as GitLab to do GPG signing of both the package content and the metadata content.
Package content and beta testing.
Metadata content. So there's divergent conversation, but there's package like itself, the actual deb file, and then there's the package lists metadata. So like this is actually the one that I have, and I have signed the fact that the list contains the version that I've made that contains the signed content. It's like layers of confirmation. Okay. Okay, it's 4:18. We got about 40-ish minutes left in this session. I wanted to do a little more detail on things, but I feel like I'm not going to get to Buzzcrate, which is the infrastructure as code bit. So I can walk everybody through, like, this is Docker running a thing, this is Docker Compose running a thing, and this is k8s running a thing. Or I can kind of like jump wholeheartedly all the way into Buzzcrate stuff. So before I just do that, for the people that are here, are you here specifically for the infrastructure as code kind of stuff? Or do you want me to walk through the rest of the building blocks stuff? I don't have the time to do both, though I wish I could.
I think I'd rather see stuff running with k8s, so.
Okay, let's focus on this. So the Buzzcrate, to quick answer, Buzzcrate is our project that is like the exploration and approachable means of doing Terraform and Ansible to deploy Kubernetes, and then being able to use that Kubernetes for development purposes to deploy applications into, including building containers from scratch in a secure fashion, and then deploying those into a functional application, all in the cluster that you deploy. It's on GitLab, but it's not a GitLab project. Myself and the host that was unable to be here were the ones that actually created it. So maybe if you all talk to me later in the weekend, I'll get you set up with the appropriate stuff, and you can walk through it. And we can give you all the rest of that so that you can play with it. So since we may not get to that, Will, hi. Thank you for your work. And we do also have a number of recordings that I can actually get you the links to from YouTube, where we presented this at Open Source Summit and a couple other things. Okay, so we're going to focus here. The rest of what we're going to do at this point is this is running a container in Docker. This is running a container in Docker Compose. I'm going to use Docker Compose as an example in particular because it allows us to see complex series of containers that make up a whole application, and then the problems of it being on a single node. And then I'll walk you through some of the major components of what a Kubernetes application is, and then we'll deploy one. Okay? I say will because it'll be on that machine there. You know what? Before I get into this, anybody want to guess how old that machine is?
Been sitting here 2 hours.
Not quite 11. No. It's actually 9.5. Yeah. The point is that you can run Kubernetes on newer hardware, older hardware, and you might be surprised what you can run it on well enough to do reasonable development work. That is an FX 8120 with 57A series. So it's got, I mean, it's one of the few that actually has 4 channels of RAM. So it's got 32 gigs of RAM, but, you know, I built it in 2012, 2013 for $500. And then I put more RAM in it last year because I didn't need the box anymore. And I was like, oh, I'm going to use it for a server. And then I realized I don't need it. So it's been sitting in my basement. Works just fine, though, doesn't it? I mean, I've been running all these demos and everything. I haven't been doing anything heavy, no. But if I look at what I have running, I've got an instance of GitLab running on that right now. Yeah, sure, it's kind of overkill for one small instance, but I got 8 cores and 32 gigs of RAM. I could probably run a full cloud native GitLab installation at scale for 300 users. I might want more than one SSD in it though. Just saying. The point is, that machine might cost you $200, $300, depending on where you bought it from. The little stack of ARM boards in front, I can guarantee you that that stack and the router to make an entire cluster like that costs under $500. You can do a lot with a little bit of hardware. And using the forms of Kubernetes that we'll talk about when we go to deploy it, you can do it really easy. Okay, back to it. So, Docker run. How many times have people run Docker run and not really known what's inside the container? Probably more than anybody wants to admit, right? Like, now that I think about it, I don't really know. Because how many people inspect their containers? Well, now you know how. Well, when you're running them, do you actually go and read how to run that particular container? No. At most, you might actually go and read it and do Docker run and like, that's weird, where's the data? And then you might read the wiki and it says, okay, well, you need -e user equals something. And then it says that's how you control which user you're running for that application. They might say, oh yeah, you probably want to store your data outside, use -v. What's it do? Right? So let's Docker run GI RM Nginx. Okay, but what's it doing? Kill that container. I'm actually going to add a few more flags here. And I'm going to background it. Right? So there we are. It's listening on port 80. So if I curl that, where's my mouse? Thank you. Let's see if I can resolve Nginx. Nope, figured not. Okay. I'm going to have to get its IP address. How do things find it? Yeah, this is the fun one. So the short answer is like that, not very well. And I could use I could sit here and type out the JQ to actually run docker inspect and then specifically go down into the state and then pull out the IP address. But that would be blind for y'all to know where it's at. That's why I was okay, I'm just gonna scroll down and grab it out.
So did that pull an IP from the network? Or randomly assign it an IP?
So it's more like a VM in terms of randomly assigning an IP.
So it's a random assigned IP on the internal network on that box?
Yes. There's actually a bridge, and on that bridge is actually DHCP, and on that DHCP is an assigned range. Yeah, which you can control. So it's there, it works, right? So now we have Nginx, but where is it serving this content from? Do I have a dash there? Yeah. Okay. So I'm gonna go figure out where it's serving from. Well, of course, that makes sense, right? I'm just going to grab that path for a second. Now, I'm going to say docker. I'm going to stop Nginx, go ahead and get rid of that one. Let's see, that path is here, so we care about that part of it. I'm just going to go ahead and make a directory. Make sure the permissions are right. Look at the Docker run again. And then I'm going to add one more thing. Actually, I need to map that whole directory right onto it. This angle is really hard for my hit. Is that the right path? I can't see. No, I very specifically want just those backticks, because Bash will interpolate the result of the pwd command, so I don't have to type here's my entire path. Because yes, believe it or not, the Docker command natively requires the full path to a host path. So yes, because the API won't know relative to who you are, it will know relative to the system. So you can't use relative paths. So if I do that, I actually get a 404. Now, you'll notice this time I got a 404 instead of the welcome page. I did something goofy. I didn't bother to make sure I was actually copying in the same file that it was intending to serve. I just made an index.html instead of, say, whatever it was actually trying to use. Hence, Nginx looked for it and exploded. So I goofed something there, but the point is that you can mount with a volume file, or -v, to actually tell it take this file from here and stick it in a container at that location. So that's what you do with your data. Is you pass it a path, and then you have your data outside of the system. Which, by the way, if you need to migrate it from inside the container to outside the container, shut the service off, stop the container, and then copy it. Because you can use Docker CP to copy the content from that container before you delete the container and get the data out. Technically, you can do it while it's running, but databases, running data, be careful. Hmm?
Is your directory executable?
Yes.
The one you announced.
Yes. I probably gaffed something. What was the path it wanted? No, I don't know. I lost it off my keyboard. Okay. So you do that, and then you actually end up using also another flag. So we had a mention of the expose flag earlier. Expose or -p actually tell you, I want this port to be exposed on the host and have it route to this port on the container. And so if I were to do the same run, here we go, -p, and I'm going to say 9001 because it's over 9,000. Really? Oh, thank you. Valid reference. Oh, because I deleted the character and then hit run again. Okay. Now, you see what happened there? Now I'm going to localhost. I'm not going grabbing the IP and running on that one. That's listening locally. Oh my word. And tilting my head while trying to type is driving me nuts. You can see that I've now got port 9001, right? But I ran NTLP. I should get the process. Well, let me run it again with sudo. So if I look at 9001, right there, you see it shows as Docker. Because Docker is actually serving as the proxy in between. You don't actually know what the process below that is, because the process below it's in another namespace on a different port, on a different network card. But now I have the host, so I could hit 00, I could hit my host name, I could hit localhost, and it will all end up routing to that container. Uh-huh. So that's like we're going deeper. There is a way to go, okay, but which one inside of Docker is that? You can trace it back, but I'm definitely off where my mind was. That's fine. So we keep typing out this command, right? We keep doing this, and it's going to get more and more complex if you have more data durs or more environment variables. Like, imagine this thing getting like 10 lines long. Which, by the way, if you look at my service unify script I have on my network services box, it's a script that goes out and pulls the latest version of the unified controller, stops the old one, and starts the new one with all the mounts back together. It's a 20-line bash script, and there's 17 lines of Docker run. I should probably make that a compose file instead. Now, this is actually what I have spun up for the GitLab instance right now. Sorry about the mic. Now I have Docker Compose. You basically define what your services are. You define what their volumes are, and then you can tell them to bring it all up. You can actually also define network too if you choose to. What we have here is I have a Postgres image because we have a Postgres database that we need. For that, I have what image I want. So I'm specifying Postgres 11. So to an earlier comment, that is actually going to pull the Postgres image from Docker Hub and at the version, 12. And then we have some environment variables that I wanted to set because it will start up and set a password and set a username so that my application can actually talk to it. I need to have a database. They have internal entry point patterns that will make that database with that user and that password. And yes, this is literally checked in to get because it's the demo that you run on your local system. And then we have volumes. And you can see we have a file brought into a specific location because that container, if you pass in a init to be, it will actually cause this during the initialization. Right? So this is complex here, but it's not that different than what we just did. If I passed -e, I could set Postgres equals that. If I pass -v, I can pass in the individual file to a specific location, just like that. But now I don't have to remember how to run docker run to this command with these exact arguments all the time. We do the same thing for Redis, except we do one tiny change. We change out its entry. No, this isn't Docker. So we change out its command so that we're actually saying Docker server, but we're controlling where the configuration is at. We're just telling it the path to it. And then we're mounting ours in there. Okay? Here's a big nasty for you. This one here is actually the web service configuration. Imagine if you had to pass all of these environment variables and tell it the command with a couple of arguments and 1, 2, 3, 4, 5, 6, 7, 8, 9 volume flags. Just looking at that, that's 20 flags. How long is that command going to be? Too long, period. And this is one of 12 containers. Of the 12 containers, half of them are like that because the number of shared secrets and environment variables that have to go around. This is why Docker Compose was created, because having to manually wire up all the various containers and their networking and where they are, when you use them like this, you actually get internal DNS inside of Docker that will actually point it to where it needs to be. So this instance of the GitLab application container can just refer to Postgres as Postgres, and it'll get connected to it because it'll have a internal to the Docker network name, Postgres. Okay, so internally, not externally, it handles your DNS. But if you don't have something like this to try and define a complex series of containers that make up an application, you're going to have an absolute pain. Now I can scroll through the rest of these, but here's a port example. We did -p 9001 to 80, right? For this application, it's what host port do we want, and then map it into port 8081. And there's a few of them because we have 8081, we have 8080, we have a few, right? But again, it's just like, And the nice thing that they have is depends. It won't actually start that container until the Postgres and the Redis are actually up. Because an application without a database is a mad application. Yeah, so say I pulled this up for a reason. So here example is our container registry, right? Our GitLab's Docker registry. And you'll see a few of them have healthy beside them. I didn't go into the details because I didn't want to go too deep on Docker files, but it does matter when we start talking about Kubernetes. You have two things that actually exist. In Docker, you have the health check. The health check is a script or an endpoint that is supposed to pull on a regular basis that actually will say from inside the container, I am healthy, or my application is returning an HTTP 200 that says I'm actually up and running, therefore I'm healthy. Things like that. That can be a script that literally does a PS grep to make sure that your processes are running, or it can be an endpoint that you can actually curl and it will do an HTTP request. If those ever don't pass, or they don't pass and they fail a couple of times, it will flip from healthy to unhealthy. And when you say depends on as a part of Docker Compose, it will wait for those things, in this case Postgres and Redis, to come up and say healthy before it starts the application. Because why bother, right?
Yeah, so you can make it very custom to the particular service. So like for Postgres, they use the SQL and just select one. And it comes back like, oh, it's running.
Yes. So like we have some services that are HTTP services. We also have some services that don't speak HTTP at all. Then obviously we can't use an HTTP request for that one. So we do actually have some that will run an internal health check and check more than one running binary inside and then do that. It's actually done in the running container. It's actually executed against the operational environment.
Compose is just a fancy front end to Docker. It's really all Docker doing it.
Yes. It's all done, like, right. When the health checks, Docker will tell you the health checks with or without Compose. If you define the health check, Docker will operate the health check. So if I were to go vim, I can type my own company's name, I swear. Right? There's a health check declaration. And this container, anytime it's used within a system that understands what the health check declaration is, will check it every 30 seconds with a 30-second timeout, and it will run that script. But that's an example definition. It won't run it continuously. The daemon will actually just run it every 30 seconds. Yeah. If your application is like a web server, you'll actually have something that's saying, I'm healthy. So that it'll just curl it, basically, every so often.
I don't know if this is out to try to scope a little bit. I've never used the health check in the Docker file. What I need to do is put the equivalent in a Kubernetes manifest.
Mm-hmm.
Do you know if Kubernetes respects that?
So it does Kubernetes respect the health check within the container's definition? Honestly, I don't know because I've never trusted it. I've always just specified it myself. Yeah. The way that Kubernetes and Docker approach health checks, in the end, they're the same, but the way they implement them is ever so slightly different in terms of default patterns. Kubernetes will implement a health, not necessarily a health check, but a liveness check, that if you don't tell it, it will actually try to reach it over an HTTP. So if you... Yes, but you have to, like, if you want to use something other than HTTP, you have to define that you want something else. Whereas it's usually best to be explicit depending on your application and environment. Yeah. In the back.
What would be the best way to handle centralized logging?
I'm not going to touch that today. Somebody asked about the best way to handle centralized logging. One, there's whole ecosystems for that. And two, that is way deeper than we want to actually end up going. Right, so I have that actually running, right? Let me grab the terminal where I actually started this GitLab instance. Remember when I mentioned str8 earlier because this just kind of scrolls by continuously about the logs? That instance is up and running, and I could restart it by doing Docker Compose restart, or Docker Compose down, let it be down, scratch its data, Docker Compose up, and it would bring it all back up with new volumes, and off we go. And the nice part is, because it's Docker Compose, because it's a YAML file, because it is a declarative almost definition, yeah, I got a nod for that one. Yeah, it is declarative, but it's not, doesn't behave the same way with the result of the declarative. I can do this all day long. if I screw something up, I can check out a copy from 2 weeks ago, start that version up, and it's just going to work. I don't have to have a shell script that I manage. I don't have to, is the syntax right? Did I put the volume name in the right place? Right? As long as I have it defined and clearly and I follow the documentation, I can repeat this on more than one system without a problem. But I'm limited strictly to Docker. And then on top of that, to Rich's question from earlier today, how do you get things on your local network or a remote network to know where it is? That's a good question.
Also your local mounts.
Yes, local mounts do require them to actually exist. And yes, Docker Compose supports relative paths because it will derive them, but Docker itself doesn't. So yeah, that's the problem, is those mounts are specific locally. Like at the very bottom of that file, I have volume declarations. And you can see a bunch of them are temp-fs. So when the volumes are no longer in use, they're gone. Right? Don't do that with real data, obviously. It's a horribly bad idea. The nice part about this is I'm going to do just Control-C, because I didn't background it, and now I'm going to shut down the entire instance without even trying. Just bye. If I passed it the background flag, it would run it in the background, and then I could do, Docker log and Docker Compose status and ls and restart. But because I didn't, when I hit Control-C, it'll shut the entire application down. This is really handy for less complex applications, to be fair, because you can do your development, test everything, and then shut it off. And then when you come back the next day, you run Compose up again. Here's your whole application state. You're not sitting there burning energy. Right? Okay, we are at 4:48. So, who here has no idea about Kubernetes right now? Okay, define no idea for me. Do you know the basics of Kubernetes? What is a deployment? What's a pod? What's a config map or a secret? I'm getting a bunch of nods. Okay. Then in that case, presenter view. I have a presentation for this. So this is actually a workshop that I've given at GitLab Contribute, which is our company together. It's Kubernetes 102 and explains how things actually work. So now what's interesting is the CNCF that we mentioned earlier actually produced a couple of children's books to kind of explain how Kubernetes works. This short presentation basically explains what those parts are and how they work. This is literally from what's called Fippy Goes to the Zoo, and we won't cover everything that's in it, but I can get you the link to it. It's free. You can get a hardback if you want. You do have to pay for that. So the first animals they came upon were the size of squirrels, furry and blue. Each little animal carried a tiny box as they unceasingly zipped back and forth. Those, said Fippy, are pods, and all day and all night they run back and forth carrying their little containers. Is that all they do, Aunt Fippy? Yep, see, for their entire lives, that's all they do is run. So pods are units of work. Okay, so we talked about containers, and we talked about volumes, and we talked about a couple other things. But a pod is one or more containers that make up a unit of work. These particular containers share a network namespace that we spoke about. So if you have two containers, let's say you have Nginx in this one, and you have a Python app in this one running Flask. They can actually reach each other over TCP from localhost because they're sharing a network namespace. And you can have volumes in the pod, say this pod needs a specific file from somewhere on your file server. You can say, I need this volume from that file server, and I need you to put it here. And then you can tell it this container gets that file at this location inside of that pod. They are self-contained units, and you can have 1 or 100 that all do the same exact thing. The idea is if you need more, you just make more, but you know that this unit of work is identical to this unit of work. A group of iguanas gathered near a large slingshot along the shore of a pond. An island stood in the center of the water. An iguana threw herself into the slingshot, and the other iguanas launched the little beast toward the island. The deployments release a group onto the island. Right now, they're trying to get 3 out there, said Pippi. At the moment, another iguana rocketed into the air, but missed the island with a big splash on the other side of the pond. Pippi said, if they miss, they just keep trying until they get as many as they need? The answer is yes. A deployment is a declaration of a number of pods. You literally describe the pod, and then you describe how many you need. It's that simple. If I have a deployment, and I want to have 3 pods running at all times, I want to have 3 replicas of the exact same workload, just in case one goes, oops. A deployment says I want 3, so Kubernetes knows, make 3, and if one dies, stand it back up. The other thing you can do with deployments is you can version them. Same name, same property set, but now say you've changed the container version from 0.1.5 to 0.1.6. It will roll that change out. So as you change it, you can say, I only want you to have 3, but I need you to update, and I always need to have at least 2 alive. So it'll say, oh, I need a new version. Okay, I'm going to roll 1 of them. And once it comes up on the new version, okay, I need 2 of them. And then once you've got 2 here, it'll then roll the new one and take the last one of the old one out. Why does versioning here matter? You can do that backwards. Yes, we have an associated set of work as well. We didn't have time for that today, I apologize. Several stone pillars arose from a grassy knoll, and at the top of each sat a vulture, and Z and Phippy watched. One vulture spread its wings and flapped off into the distance. No sooner had one left than another took its place. Z asked, what are they doing? Those are daemon sets, Phippy said. They make sure to occupy every pillar, rain or shine, day or night. I bet that if we added a new pillar, a new bird would land on it faster than you could say, cube cuddle, chuckled Phippy. Daemon sets are like deployments, but they're a little bit different. Daemon sets will make sure that you have a pod, 1 pod, on every node that daemon set cares about. In this case, the vultures care about every single pedestal, and it will make sure that there's 1 pod running on every single node or every single pedestal. This is important. Say, if you have a logging daemon, you want to make sure that your logger is there and collecting the logs from every single node and not ignoring them. A deployment doesn't care where the pods go. Daemons say, I go 1, I go 1, I go 1, I go 1 across the board without question. There's some control, but every single one will get them. Deployments, if you have 3 nodes and you say, I want 2 pods, it will randomly pick 2 nodes and run 1 there and 1 there. If you say have 3 nodes and say you want 40 pods, I hope you have room, but it will put 10 here, and it'll try to figure out where to balance the other 20. You might end up with 13, 13, and 14. You might end up with 15, 12, and 13. Daemon sets will always be 1 here, 1 here, 1 here. Now, there's not a book page for services, so we made one. Services are effectively the network version of how do I reach the thing and how I make sure that it gets to a live functional container inside of a pod. Services are a network name or a network address. Behind that are all the pods that are marked live and healthy. If you're not healthy, you get knocked out of the service loop and it won't send traffic. If you're not live, guess what? You're definitely not in the loop. As you bring new pods in and they become healthy, they get added to the service. As they are rotated out for upgrades, the same process that happens with deployments. Pod goes out, new pod has come in, it gets added to service, the old one goes out. And repeat. But the nice part is the service doesn't care. These are the pods it cares about. It doesn't care what version. Have fun. Yes, there are finer grained controls so that you can make it care about version. Okay. That's the right one. This is the one you're going to care about. As they walked on, they saw an aquarium with an enormous reef. Edge to edge, it appeared that the rock would keep anything from passing from one side to the other. Z watched as hundreds of tiny fish made a dash for the center of the face of the rock. At full speed, the fish swam into a hole bored in the rock and momentarily vanished from sight. Z let out a gasp. Multicolored flashes erupted from the opposite side of the coral. Instead of coming out from a single hole, the fish seemed to just materialize from tiny fissures all over the far side of the rock. Ingresses are beautiful, said a dreamy-eyed Fippy. Enchanted, Z muttered. Ingress. So, here's a fun one. How do you send traffic from the outside to the inside and actually know what it's supposed to do? Services are a network address, literally an IP address and a port. And whatever pods that it's supposed to care about that have a port that lines up to its port will get traffic if they're live. Ingresses allow you to route and correctly order where HTTP traffic goes based on hostname. So you can tell it just like it's an Nginx or a Traffic or a Caddy or any other web server, or Apache if you really wanted to drive yourself a little nuts. You can configure your hostname, and on that hostname you can configure your TLS, so it will terminate your TLS for you, and then you can say, I want everything that goes under this path to go to that service. So let's say you want all the traffic that's under API to go to a specific set of workers or pods in a deployment. You can say, when I go to example.com/API, I want all of that to go to these API-specific workers. It could be the same code, but maybe those ones have more CPU or more RAM because APIs need more. And maybe you have /login goes somewhere else that's a completely unrelated piece of container code. But if you go to /, it just sends everything to a web server that's just HTTP and HTML. Nothing fancy. Just has your content. Or maybe you want /assets that has all of your JavaScript, your images, and your CSS just mounted to an Nginx container so that it can just do its job real fast, real easy. Ingresses have the ability to route specific traffic to specific places.